Today is our first day of notes. We're doing Chapter 1, Section 1, which is solving simple or one-step equations. At any point in this video, if you need to hear something again, please pause the recording. You can also rewind and go back. An equation is when two expressions are equal to each other. So when you have something equal to something, that's what we're talking about with our equations. When we have a linear equation with one variable, that's when we're solving an equation for one variable. We're trying to get either x or y or z by itself. We want to remove everything else and move it to the other side of the equation. Our solution is the same thing as the answer. Those two words mean the same thing. Solution is finding out what x is equal to or what y is equal to. Inverse operations are operations that undo each other. So addition undoes subtraction, multiplication undoes division, and so forth. Equivalent equations are two equations that are equal to the same thing. So we've got some properties of equality, and all of these properties of equality tell us the exact same thing. As long as you do the same thing to each side of the equation, you haven't changed the value. You've created an equivalent equation. So if I have a equal to b, and I want to add something to my a term, like c, I can do that as long as I also add c to the other side. So if I have 3 is equal to 9 over 3, then if I wanted to do 3 plus 2, I would also have to add the 2 to the other side of the equation. Otherwise, they are not going to be equal to each other. The subtraction property of equality tells us the exact same thing, only now instead of adding something to both sides of the equation, we're going to be subtracting something from both sides of the equation. So if I have a is equal to b, then I know that if I subtract c from one side, I have to subtract it from the other side. And if I do that, we know that we've ended up with an equivalent equation. Our multiplication property of equality, same idea. As long as we do the same thing to each side of the equation, we get an equivalent equation. So now we can multiply both sides of the equation by something. Division property of equality, once again, as long as we do the same thing to both sides of the equation, and in this case, we're dividing both sides, then we haven't changed the value. So some general problem-solving strategies. These are strategies you can use throughout the whole year. So using a verbal model would be writing out the words into an algebraic equation. You can draw a diagram or a picture. You can write an equation, look for a pattern, working backwards. Guess, check, and revise is one that's often overlooked. Being able to guess an answer is an important skill as long as you're able to go back and check it. And then if it doesn't work, going and finding a different answer to try and check. You can always sketch a graph, make a number line, make a table, make a list, or you can break the problems into parts. So as we get to our first practice problems, as we're working through these, you want to make sure that you are able to do these problems yourself. So before I start working the problem, you would want to pause it, start on problem number 1, and then come back and check and see if you got the same thing. So work the problem and then have me work it and make sure you are able to do the same thing. On any of these problems, if you don't understand what I did, watch it a second time. If it still doesn't make sense, that should be something you're starring in your homework to make sure that you come back tomorrow in class and you're asking questions on it. So if we look at number 1, I have w plus 4 is equal to 16. I want to get w by itself. So the first thing I'm going to do is ask myself, what is keeping w from being by itself? Well, that's this plus 4 right here. If I can get rid of that plus 4, then I'm able to get w by itself and I'm able to solve it. So I have to decide how to get rid of adding a 4. The opposite or the inverse operation of adding a 4 is subtracting a 4. If I subtract a 4 from this side of the equation, if I have w plus 4 and then I subtract away the 4s cancel each other out and I'm left with just w. But because I subtracted a 4 from one side of the equation, I have to remember to subtract 4 from the other side of the equation. Otherwise, I have changed the value. So 16 minus 4 is 12, and I've got my answer. You always want to go back and check your solution. So what that means is you're taking your answer and you're plugging it back into the original equation. So if I'm going to check this, I'm going to take w plus 4 equal to 16, And instead of W, I'm going to replace that with what I found W to be equal to. So I'm going to have 12 plus 4. Is that in fact equal to 16? Well, yes, it is. So it checks out. So I know that I haven't made a calculation error. If I plug my number back in and it doesn't work out, that tells me I've done something wrong and I need to go back and fix that. So now looking at number 2. So I have x plus 7 is equal to negative 12. From here, I want to get x by itself. So I think 7 is the only thing keeping it by itself. How is 7 attached to x? It's attached with addition. The opposite, or the way to undo addition, is with subtraction. So I'm going to subtract a 7 from both sides. If I do it to one side, I have to remember to do it to the other side. My 7 cancels out on this side, so I'm left with x is equal to, and then a negative 12 minus 7, be careful with your math, is a negative 19. Remember, subtracting a number is the same thing as adding the opposite of that number. So negative 12 minus 7 is the same thing as negative 12 plus a negative 7, if that helps you calculate it. And then again, we want to go back and check our answer. So if I were to plug in a negative 19 for my x, I would have a negative 19 plus 7 equal to negative 12. Is negative 19 plus 7 equal to 12? Yes, it is. So I know that that's my answer. All right, the next one, a little bit trickier. We have w being added to the negative 15 equal to 6. However, the negative 15 is listed first. If I were to think about the opposite of addition, which is the sign I have right here, it would be subtraction, but it's actually the w I'd be subtracting. So instead, we want to think about how I would get rid of a negative 15. If I'm adding a negative 15, the opposite of adding a negative 15 would be actually adding a positive 15. Negative 15 plus 15 cancel each other out. So I'm left with just w on this side. But if I do it to one side, I have to do it to the other side. So I have 6 plus 15 gives me 21. And again, I always want to go back and check my answer. So negative 15 plus 21 equals to 6. Does that work out? Yes, it does. Okay, on to the next one. Now we have a subtraction problem. So z minus 5 is equal to 8. If I add a 5 to both sides, that's the opposite of subtraction. So minus a 5 and plus a 5 cancel each other out. So I'm left with z is equal to, and then I just need to do the math on the other side. 8 plus 5 is 13. Okay, on the next one, our variable is on the other side of the equation. However, we're still going to solve it the exact same way. If I have negative 2 is equal to w minus 9, the 9 is what's keeping w from being by itself. The opposite of subtraction is addition. So I'm going to add a 9 to both sides. These 9s cancel out. I'm left with just y. And on this side, negative 2 plus 9 is equal to 7. Notice it's okay to leave your answer like that. If you'd rather rewrite it with the y on the other side, that's okay as well. Either one of those are okay. We do want to check our answer though. So I have negative 2 is equal to 7 minus 9. Is negative 2 equal to 7 minus 9? Yes, it is. So I know that that is my correct answer. All right, the next one. How is 7 attached to q? It's attached with multiplication. The inverse, or the opposite of multiplication, the way we undo multiplication, is with division. So we want to divide both sides by 7. Notice I'm using the fraction bar for division. I'm not using the division sign that looks like this, because as we start to get to more complex problems, we want to make it very clear what we're dividing by. And so using the division sign right here is less accurate. So we want to stop using that, and we want to start using our division bar like we have here. So if I have 7 times q and then I divide by 7, my 7s cancel out. I'm left with q equals, and then I do 35 divided by 7. 35 divided by 7 is, you guessed it, 5. Checking my answer, is 7 times 5 equal to 35? Yes, it is. All right, moving on to our next one. We have 4b is equal to negative 52. From this point, we need to decide that 4 is attached to b by multiplication. The opposite of multiplication is division. So I'm going to divide both sides by my 4. 4b divided by 4, well, 4 divided by 4 is 1. It cancels out. I'm left with just b. And negative 52 divided by 4, well, a positive divided by negative is a negative. And then 52 divided by 4 is 13. For the next one, we see that q is being divided by 11. The opposite of division is multiplication. So we're going to multiply both sides by 11. Notice I use the multiplication dot, not the